As the interstellar comet 3I Atlas hurtles toward our solar system, new data is emerging that signals a catastrophic threat to our entire existence.
Well, first thing, it implied that it came from outside the solar system because gravity cannot bind it to the sun.
What was once considered a cosmic curiosity has now become an alarming reality.
For centuries, humanity has watched the heavens, captivated by comets and asteroids, the restless wanderers of our skies. But sometimes, the universe delivers a visitor so rare, so clearly not from our own neighborhood, that astronomers pause and reconsider what they thought they knew about our place in the cosmos. On a quiet night in early July 2025, a NASA-funded telescope scanned a humble patch of the sky, searching not for anything in particular, but simply watching, as it always does, for anything out of the ordinary. That night, a faint, emerald-tinged glow emerged at the edge of its vision. Over the following days, this tiny, mysterious smear in the darkness would come to captivate observers around the world. News headlines, scientific debates, and nights spent glued to observatory monitors swirled around this object, quickly named 3I/ATLAS. Interstellar comets are extraordinarily rare visitors. Before 3I/ATLAS, only two others had ever been confirmed to journey into our solar system from the vast spaces between the stars. 1I/Oumuamua in 2017 and 2I/Borisov in 2019. But 3I/ATLAS was different. It was brighter, grander in scale, and displayed an evolving tail, a spectacle steadily revealed in new high-resolution images. Its path placed it on a course that would bring it closer to the Sun than either of its predecessors, and would even bring it near Mars, an unprecedented encounter for an object not native to our solar system. With each observation, astronomers wondered, what secrets did this glowing green visitor carry? Would it shed new light on the origins of comets and the matter between the stars? In the chapters that follow, we trace the journey of 3I/ATLAS, peeling back layers of mystery to piece together all we know and all that still waits within the darkness. The path of the interstellar stranger. Unlike the countless comets that wander through the outer edges of the solar system, 3I/ATLAS was confirmed as an interstellar object, a body whose journey began light years away from other stars, not within the orbit of our Sun. Astronomers first spotted 3I/ATLAS on July 1, 2025, using the powerful ATLAS survey telescope. Initially, it might have passed for another minor moving dot in the star field, but its velocity and trajectory quickly marked it as an outlier. While most comets travel along closed elliptical orbits tethered to the Sun, 3I/ATLAS charted a hyperbolic path, one that would carry it through the solar system and back out into interstellar space, never to return. Astronomical calculations traced its closest approach to the Sun to around October 30th, 2025, at a distance of roughly 1.4 astronomical units, that is, about 130 million miles, just inside the orbit of Mars. This dangerous plunge offered the chance to observe how such an object would fare under conditions that can break apart even native comets. Compared with its two predecessors, 3I/ATLAS promised an even more intimate view. 1I/Oumuamua quietly zipped past, enigmatic and silent. 2I/Borisov blazed in from the edge of the solar system, but at a safe remove. Now, 3I/ATLAS would pass nearer to both the Sun and Mars, giving astronomers a rare opportunity, not only to watch an interstellar comet up close, but to see how it interacts with a planet. This proximity was exceptional and raised compelling questions. Why did this interstellar traveler, among the billions adrift in the galaxy, end up on a path that led so close to our star and to Mars? What might we learn about other star systems from this encounter? As each new observation arrived, the anticipation only deepened. Unveiling the comet's alien signature, images soon revealed 3I/ATLAS's most striking feature, its coma. The coma is a cloud of dust and gas that forms as sunlight heats a comet's surface, vaporizing ice and releasing gas and particles. But for 3I/ATLAS, the coma shimmered a distinct, vibrant green. Astronomers explained this color as most likely the result of the breakdown of diatomic carbon C2 and other molecules under solar radiation, a phenomenon occasionally seen in solar system comets, but unusually prominent in this intruder. During a lunar eclipse on September 15th, 2025, 3I/ATLAS's green halo became even more prominent, its ghostly glow visible to amateur and professional astronomers alike as it drifted against the darkened sky. As September unfolded, new images revealed a lengthening, increasingly dynamic tail. The tail's form and activity adjusted in response to changing solar conditions, and the amount of dust and gas pouring from the comet seemed unusually vigorous for a body on its first known passage near the Sun. Initial data suggested its nucleus was substantially larger than either Oumuamua or Borisov, making it by default the largest confirmed interstellar comet ever observed. This increased scale, combined with its energetic outgassing, offered an unparalleled window into the kinds of materials and internal processes preserved in bodies formed far from the Sun. For planetary scientists, each new spectral measurement, each detail of the comet's glow and dust was a clue to the chemistry and origins of materials outside the solar system. As 3I/ATLAS's approach unfolded, hopes rose that this unique encounter would answer long-standing questions about the raw ingredients formed in other stellar nurseries. A close encounter like no other. As October approached, 3I/ATLAS continued its rapid dive toward the inner solar system. While most comets are content to skirt the distant reaches of planets, this object's path would bring it near enough to Mars to draw special scientific attention. The comet's approach to Mars was not only rare, it was unprecedented for an interstellar object. No previous interstellar visitor had come close to any planet after entering the solar system. Martian orbiters and rovers were quickly put on alert, prepared to track this event as it unfolded. For planetary observers, this encounter prompted critical planning. Would the comet's dust interact with Mars's atmosphere? How would Martian skies respond to the brief passage of alien particles? While significant effects on the Martian environment were considered unlikely due to the distances involved in the comet's closest pass, the event presented a chance to monitor for subtle changes and perhaps even capture interplanetary dust from a truly foreign body. The potential for new discoveries inspired many. From Earth's surface, telescopes were cued for time-sensitive observations. On Mars, orbiters prepared their cameras and spectrometers. For the global planetary science community, amateur and professional alike, this was a moment to watch closely, to gather every available data point as history passed in front of our eyes. Cautious speculation and the boundaries of natural law. As excitement mounted, speculation entered the conversation, a natural response to the presence of something so unusual. some wondered aloud about the underlying causes behind 3I/ATLAS's distinctive behaviors: its mass, its pronounced green glow, and its path through the solar system. It is not uncommon for outlier events to prompt distinctive, sometimes bold, hypotheses. In the case of 3I/ATLAS, some theorists questioned whether every facet of its activity could be explained by current models of cometary physics, or if the object might challenge our assumptions about the diversity of material and dynamics possible among interstellar bodies. However, there has been no evidence to suggest anything beyond natural, though exceptional, cometary processes. The suggestion of artificial origin is not grounded in any direct observation or established data. It is not supported by the available scientific context. For now, 3I/ATLAS's story remains one of cosmic happenstance and natural law, remarkable not because it defies physics, but because it illuminates the extraordinary diversity of objects the galaxy can produce. Researchers continue to gather every new measurement, knowing that the more data they had on the chemistry, activity, and dust emissions of 3I/ATLAS, the more confidently such speculations could be addressed or dismissed. By focusing on the physical and chemical properties at hand, astronomers sought to expand our understanding of what interstellar visitors truly are: shadows cast by an emerald tail. As 3I/ATLAS swept inward, the distinctive green coma drew observers worldwide. The color, attributed to the breakdown of specific molecules under intense sunlight, was scientifically significant, offering an opportunity to track unfamiliar chemistry in the harsh solar environment. Detailed spectroscopy revealed that gases, perhaps including unfamiliar combinations, were escaping from the comet's surface at rates not previously associated with interstellar comets. The tail, too, extended and curved visibly under changing solar radiation, dust particles shifting and swirling in response to the solar wind's influence. During the lunar eclipse of September 15th, amateur astronomers and seasoned scientists alike marveled at the Emerald Show. The Earth's shadow temporarily dimmed background light, emphasizing the comet's unique coloration and highlighting the unfamiliar chemistry at play. Yet even with high-resolution data, the composition and structure of 3I/ATLAS remained complex. Certain measurements hinted at molecular signatures, unlike those in typical solar system comets. While cautious not to overstate the case, scientists noted the likely presence of ices and dust grains forged beyond our sun, shaped in distant interstellar space, now exposed for the first time to its energy. Each image contributed to an evolving picture of how different and diverse comet formation can be across the galaxy. The solar gauntlet, surviving the close October 30th, 2025, drew near. The astronomical community waited eagerly. 3I/ATLAS, the largest known interstellar comet to date, was set to pass just 1.4 astronomical units from the Sun, a region where solar heat and radiation have destroyed more than a few solar system comets. No one could say with certainty whether 3I/ATLAS would remain intact or fragment under the Sun's intense glare. Its predecessors had never ventured so close. 1I/Oumuamua had swung through the inner solar system at a greater distance, while 2I/Borisov followed a less dramatic trajectory. In the days before perihelion, observers watched for signs of increased activity. Outgassing surged, the coma expanded, and the tail responded with renewed dynamism. For those studying cometary disintegration, this was a rare and valuable window into what happens to the least altered ices available in the galaxy. a record of conditions far from our star, now rapidly being lost to space. For comet scientists, this was an unprecedented opportunity to observe the interplay between heat, solar radiation, and the most primitive materials known in the solar system. Would the comet fragment, revealing even more about its internal structure, or might it survive the approach, opening the door to continued study on its long outbound journey? NASA's unprecedented confirmation. As the encounter with Mars drew near, NASA released its analysis, synthesizing weeks of coordinated observations from the ATLAS survey program and multiple Mars-based spacecraft. The data confirmed several remarkable aspects of 3I/ATLAS. Its activity peaked as it neared Mars and the Sun, with rapid outgassing and dynamic jets of material pointing in multiple directions. Spectral analysis indicated an array of volatile compounds, including some not previously detected in the coma of any comet, interstellar or otherwise. While the detailed chemistry and mechanisms behind these emissions would take years to fully model, the diversity of gases suggests that interstellar comets can bring new, never-seen combinations of material into the inner solar system. The timing and character of the comet's outbursts, particularly apparent as 3I/ATLAS approached both Mars and its closest point to the Sun, emphasize the impact of local solar conditions and potential gravitational influences on outgassing. Yet, while the intensity of the emitted jets was striking, all available evidence pointed toward entirely natural processes. So far, there were no signs of anything except the remarkable diversity of physics and chemistry at work in interstellar comets. Though speculation had sometimes run ahead of the data, NASA's statement brought the focus back to the astonishing reality. For the first time, an interstellar body had been watched as it interacted directly with the Sun's intense radiation and at close range near a major planet. The event offered a foundation for renewed study of both interstellar comet activity and the broader processes that shape the material drifting between the stars. Reflections in the wake of the visitor. Long after the emerald glow faded and 3I/ATLAS traveled outward, its legacy persisted in the enormous troves of data collected across the globe and from Mars. Never before had such a rare interstellar object been observed so closely and for so long, revealing its story in real time. The encounter of 3I/ATLAS has sharpened our sense of cosmic connectedness. The solar system may be our home, but it is not isolated. Each passing interstellar object brings a sample of matter born in the chaos of distant star nurseries, forged under conditions we may never witness ourselves. In the case of 3I/ATLAS, we saw the chemistry of its alien origin react and evolve under the influence of our Sun and one of our planets. What does this mean for the future of astronomy? For one thing, it highlights just how much remains to be discovered, not only about other solar systems, but also about the general processes that mold planets and comets everywhere. Every new interstellar comet is a messenger, carrying signs of its distant birth and the galactic history it has traversed. As new telescopes and surveys come online, astronomers hope and expect to find more such visitors, each with their own stories to tell, their own chemical compositions, and their own paths through space. 3I/ATLAS's dramatic passage reminds us that the universe is dynamic and interconnected, and that the boundaries between star systems are more porous than once imagined. Looking back, 3I/ATLAS serves not only as a scientific milestone, but as an invitation. The universe, vast and ever unfolding, will continue to send its emissaries. Each is a testament to the randomness and richness of cosmic evolution. and to our growing ability to recognize and learn from what drifts in among the stars. So we watch the skies, awaiting the next chapter, knowing now, with new evidence and experience, that each arrival from the void may redraw the boundaries between what is known and what has yet to be discovered.